morning. So today we are going to discuss on sensing considerations. So what are the different factors which we are going to see here is the next topic is sensing consideration. So select your choice of sensor for IoT is very important. The choice of sensor for IoT is very important. And you can say that sensors in an IoT node is critically and make a break and the feasibility of IoT equipment. So if you are not selecting a proper sensor or you are not deploying a sensor properly, what will happen if it entirely spoil the entire IoT system itself? If some of the nodes fail or some of the system is not working properly, then your entire system, whatever you have established, will not have any impact. Okay. So, what are the factors which influence the choice of sensing in IoT? So, these are the things we are going to see. Sensing range means we are going to see that the range at which the sensors have to be deployed, sensing range. Then you have accuracy and precision, then energy and device size. So, these are the four things which we have to see and which we have to consider for the factors which influence the choice of sensors in IoT design. So these are the main factors: sensing range, accuracy and precision, energy, and device size. So you can just note down those things. So if we study the sensing range, then accuracy and precision, energy and device size. So each and everything is important when you are selecting a sensor device. You should make sure that accuracy is good, the device consumes less energy, and the range at which the sensor can monitor. For example, you keep a sensor at one point, it may be sometimes some 10 meters of circle or 10 meters of area, it may be able to monitor. So we have to know all those things. What is the space it can monitor, how much area it can monitor, what is the energy consumption it is going to have, what is the accuracy and precision, what are the device size, what is the size it can have, all those things. So these are the things, these are the sensing factors which has to be considered. So what are the four factors? Sensing range, accuracy and precision, energy and device size. So let us see one by one in detail. The first one is what? Sensing range. What do you mean by sensing range? Yeah, the range at which the sensor is capable enough to collect the information, whether it is from the surroundings or the space where you have deployed it, it should be able to collect the information. So what are those things? What are the parameters? So we see sensing range. Here, what do you mean by sensing range? Sensing range of the node to sense the information. So you can say that optimizing the process, sensing range is deployed for fixed K coverage and dynamic K coverage. So some cases you may have fixed K coverage, means if you connect the sensor, it is understood that this much is the specific area it is going to cover. You are not able to extend anything here and there. it is very much fixed. Or you can have a dynamic K coverage also. Means dynamic means little bit random here and there. If you are moving the nodes and all, you will be able to still vary the parameters. You can measure the parameters. Then when you are going for a long-term fixed K coverage, means you are having a node and you are keeping it for a longer duration of time. For example, you have a node which you can get for 1 month, 2 months, 5 months, 1 year. So longer duration of time. What you can see is the redundancy it is requires a large number of sensor nodes that sensing the range and which may also overlap with each other. So you might have seen one sensor node information getting overlapped with another sensor node information. And when you are going for a longer duration of time, you should also see that its durability is more and it is able to withstand all those conditions and all those things. Okay. Then the sensing range of a sensor may be also significantly upper and lower bounds and which has sensing measurement range. So there is a specific range which can be possible by a sensor node. You cannot like if you are having a sensor node which has the capability of 10 centimeter or 1 meter. So you will be able to collect the information only to that specific locality. Okay, so that is there, and you can say that one of the example is proximity sensor, which has the typical sensing range of couple of meters. So if you have a couple of meters anything, it is going to say that proximity sensor is going to say that yeah, there is these are the objects available or these are the things which are in front of the person and all those things. So you can, when it is beyond a couple of meters, like beyond 2 meters or 3 meters, it's not going to sense anything. Is that clear? So then you might have seen in the case of face recognition also. Certain extent it will be able to recognize. If you go a little far from that sensor, it will not be able to recognize that whether this is the person or whether it is not the same person, isn't it? Have you ever, you might have seen, and you might have seen in shopping mall and all, the door closing and opening. So when you enter to that surrounding only, the door will open. So it has that certain range at which the sensor will sense the information and it will do the further processing. So if you see the camera, you know that when you take close by images, you get the clarity. But if you go for a longer view, you may not get the clarity of the person or objects and all whatever it is there. So that is what camera has a sensing range varies between the meters of 100 meters. So sometimes you have high resolution cameras, you can go for some 100 meters and all. Then the complexity of the sensor and its range goes up. So what you can see, you are really experiencing these things. When you go for high-end camera, high-end fonts, high-end equipments, your definitely the cost is higher because to manufacture that which has the high resolution, the cost also it will go up, isn't it? So that is a quite normal practice which you are having. If you are using a high-end font, you will be having higher cost. Lower end, you will be having lower cost. So, but the materials are available which can give you low accuracy, low precision, which can give you high accuracy, high precision. So based on that, the cost will vary. Okay. So these are the things which you have to understand in sensing range. Then what is the next one? Accuracy and precision. You see that you can note down few points. You might have experienced this sensing range in many of the applications whichever is close by. So you might have seen that, especially in the shopping complex and all those things, you can see many different sensors they will keep to track the person if he is taking any things outside the shop. What is that called? Doctor tag. So that's one. So it will give it is going to give an alarm system. If you without taking the if you take the object outside, it is going to track. It is going to give the alarm system. It is going to make sure that yeah, this is not paid. This object is not being paid for. Okay. So all those things are there. When you move inside, automatically the doors will keep on opening. When you come outside, the doors keep closing. Then what all applications you have seen? Yeah, if you go to the washroom, you can see that if you keep the hand, the water will come. So all those things are just with the help of sensors. Yeah, car keeps having a lot of features. So all those car itself is having a lot of sensors. So based on your requirement, you have to have the sensor, and the sensing range is also based on your application. You need to decide whether how precision and accuracy has to be maintained. What is the sensing range it can accommodate and all those things. For example, if you are taking a small area, 100 square 100, so what you can say is 100 cross 100, you are taking a small area. Then you can say that how many sensors are required to track that entire area, all those things. So that is called as the design. Okay. So is that clear? So next one is accuracy and precision. So what is accuracy and precision? Accurate answer, precise answer. What is accuracy and precision? Yeah, accuracy means if you are, for example, last time also we have seen accuracy. You know that it is 50 degrees centigrade. Its room temperature is 25 degrees centigrade. Let us say 25 degrees centigrade. You know that. Accuracy means it is showing exactly 25 degrees itself. It is accurate. Precision means what it is 25.005001. So to be very precise, what is the exact reading? So we will see that accuracy and precision measures provides the sensor the critical operations of specific functional processes, and it is limited to regular application domains. So based on your requirement, you can decide whether you want very precise equipment or very much precise devices. Sometimes that much for you see, for example, finding out the room temperature of this room is not that much. We don't want that much accurate and precise because slight variations here and there of the temperature variation will not impact anything, any ecosystem of this room, isn't it? But if you go to an industry where the precision is very important, or when you are launching a satellite, or when you are taking any defense applications, where the precision is very important, you have to go with precise equipment. You have to improvise the precision of the sensor. So, regular temperature sensor, it is low temperature sensing range and relatively low accuracy and precision. Normal, if you are measuring the temperature, it is not required to be too precise and all those things. But that is not the case if you are going with industrial applications. So when you are going with industrial application, precision of up to 3 to 4 decimal places is very important. As I have told you, maybe a small variation in the temperature. For example, when you are doing some combinations of chemicals, or you are doing some combinations of something for preparing medicines and all. For you are preparing medicine, you are having a space where in a room where you are developing some medicines. So where the temperature if it goes slightly above a certain point, the property of the medicine may change. So those kind of places you have to be very precise and accurate. You cannot compromise saying that okay, if it is 25 degrees centigrade also okay, 30 degrees centigrade also okay. So you have, it is not possible. So those cases, the industrial sensors will be very much sophisticated, and when you are going for very precise temperature sensors and all, your cost will also go ahead. Normal temperature sensors won't work out there because there the precision is very important. So your cost will also go slightly high. So industrial sensors will have very accuracy and will have very much precise score, and which will give to the good operation conditions for the industry. And when you are going for precise and accurate sensors, automatically your cost is going to be high. So that is about accuracy and precision. So what next is there for us? Energy. Energy also we have discussed. So if you have done with that, we go with energy. So let us see what is energy. So what is your opinion about energy and why energy is required? What is energy? So now we have seen precision and accuracy. Before to that we have seen sensing. So here we have seen in the previous slide we have seen sensing range. Then we have seen accuracy and precision. Now let us see what is energy. What do you mean by energy? Energy is what? See, I have brought one sensor node to you know. So how that sensor node will be driven? With the help of a battery. Okay, if you are connecting to that wired one, it is a wireless one, so it will be charged by a battery. Means it will be driven by a battery. So what it is required? Energy consumption is very important, and you know that the lifetime solution and the estimation of the cost of deployment is very high. For example, now some places will be there, some terrain places or some very difficult places where you go once in a while only. You will not be frequently visiting. If you are frequently visiting, then why you need the sensors? If you are not frequently visiting only, you need these sensors to monitor whatever it is happening there. If you are going there continuously, why you need sensors and all? So the places where you will not be continuously monitoring means continuously where you cannot reach once in a while you go and you deploy the sensors and you come back. Further again and again you don't keep on going that place, isn't it? So those places it is very important that your sensing application should work throughout that long duration, and the energy consumption is very important parameter because of the energy parameter only the sensor will be driven to because of without energy the sensor will be dead, isn't it? Without battery whether the sensor will work. No. So if I for example you use your watches and all. So if you keep a very good battery for that and you drive, it for a longer duration, it goes for 1 year or 2 years. So like that, the sensors also will be deployed at different places. So your energy consumption is very important. If the device is taking more energy, what will happen? Your battery will drain out faster. So you have to make sure that you have to have a very sophisticated design and make sure that the energy whichever is supplied for the sensor has to be taken care for a longer duration of time. Okay. Then scenario where the sensor nodes are deployed in a very much terrain places or very remote places, you have to say once deployed, the access of the nodes is not possible again. Is it, for example, if you are going to somewhere in top of Himalayas, you go and keep the sensors there. You come down. Again, you can go tomorrow again and check what is happening there. No. Or you go very deep into the ocean. You put all the sensors there in the ocean. Again and again, 24/7, you can keep going and see. Not possible. So once you deploy it, you make sure that further you are not supposed to go there again and again. It should only withstand the process and it should give you the readings. Okay. So energy requirement of the sensor is too high and not last for long duration, and so it is very much important to keep the process charging. So either what you have to do, you have to keep the sensors active. For keeping the sensors active, so you might have observed in your home itself. If you have 5 mobile phones in your home, you make all 500% charge, but when it discharges, all 5 will not discharge at the same time. Okay. So what it is making it so like that because of the design of the mobile. Yes, no. Design of the mobile, the equipment used in that, the capacity of the battery, everything. So all those things are very important. The energy is very important for a longer duration of time for the sensor to work. So what is the next one? What is the last one? Size of the device. So last you complete this and then you go for device size. So the last one is device size. You have done with it. Can you give 2 minutes? So as we have seen the accuracy, precision, energy consumption, then the device size is what we are going to see now next. So what is your view on size of the device? See, for example, if you take about this mobile itself, if it is too big, would you like to carry this again and again daily? No. Even if it has all the features, still you will make sure that let it be at home, isn't it? Rather than carrying it or making it so handy. So you have some watches and all nowadays it is coming. So which has all the sensors inbuilt in it, which gives you pulse, then how many heart rate, and also gives you what is the stress you have walked, and all those things. So let us see that next one, device size. So the device size is very important in day-to-day applications, wherein there are some devices which are very minute that it can even go to your system inside your body and check all the functionalities of your organs and give you a report. Okay, so if it is so big, then it is not possible. So it is very important to have a proper size of the device. So applications of the concern, but when you go for sensor node deployment, which is to be carried out, it is very important to have a very low, small size and high sophisticated equipment. For example, if you should have lesser size, but its functionality should be better. Okay. So what you can say, larger the size of the sensor node, larger the options will be there, and higher is the cost and energy. When the size is more, what you can say, the cost and energy will also be. Size is more. The size is less, cost will be more. When the size is less, the cost will be more. Okay. So you can say that. So very simple human activity detector. You can say the detection unit is too large or too bulky. It is difficult for us to handle it. So because of this thing, variable process has come. So if the entire for example, I give you a very big device which measures your heartbeat, pulse, and the way how many steps you walk and all those things it will measure. Would you like to keep it with you and do all those processes daily? No. If it is so big, you will not be willing to keep it with you. But yeah, if the watch like she is having, so if it is variable, you can wear that, and it is not disturbing you. Then only you will have the size sensor with you. So the size of the sensor is very important. So nowadays variable sensors are coming, which is helping you to monitor the devices, means monitor the entire process, and highly energy efficient and small size. So small size equipments are very important in order to have a user friendly environment. Okay, is that clear for you? Any doubt is there? So these are the four things. So we will complete the sensing part of it. So what is the next one? So we have completed introduction, sensor characteristics, sensor deviations, sensor type, sensing considerations. Now we have left out with three topics, that is actuators, actuators. Selective sensing conditions. So our first complete module and second module, now you can go with the example. So our skill.